Only effective if I remember to do it. Okay, Alexis, here you go. I'm remembering today. Sorry. Okay, here we go. Okay. If the probabilities are connected with the word and, you. Very good. And remember to change the second event sample space if it is what? What was it? Dependent. Nope. Dependent. On the first event. So, what's our formula if I've got the probability of A and B happening? How do we write it in symbols? What's the probability of the first one? Multiply, because you got the word and. Be given that A happened. So we have to check if that second event, the sample space changes. Okay, that was 2 days ago. Yesterday, if the probabilities are connected with the word or means add, and remember to subtract the overlap if the two events are not, what was it? Mutually exclusive. Formula. Oh, I got a little parenthesis there. So if it has A or B, that's what you're going to practice writing today. It's the probability of A plus probability of B, then what? Minus the probability of the overlap. The ones that were double counted. Okay, very good. You remember. Oops, yep, overlap. Okay, you're going to do little carnival games over at Cameron next fall. Give you a couple ideas here in case you're in charge. Okay, your game has 2 spinners, each with 1/2 shaded. Your person will win the game if both spinners land in the shaded region. Just take a guess. What do you think the probability of winning this game is? 0.5. That's a guess.
Wait, each one is shaded halfway?
Each one has to land in the shaded.
No, but is each circle shaded half?
All right, let's draw them in. This one's shaded. Let's go. We'll even make it a little interesting. This one's half. This one, let's go. There. Are each of those half shaded? Yep. Does it matter that the one's in chunks? Still half the circle. Okay, now what's your guess? Just an educated guess. What's the probability of winning this game? Here in 1/4. 0.5. 1/6. Okay.
Oh wait, no, I'm wrong.
You're wrong. Okay, let's see. It says draw a tree diagram to show the sample space. So how many events is your person doing? Your contestant? 2. Start the tree diagram. The first event is to spin the first spinner. What can happen?
Shaded, not shaded.
Shaded or not shaded. What's the probability that it lands in the shaded on the first spinner? 1/2. Let's put that there. How about the second spinner? The probability there? 1/2. Okay? Second event is to spin that second spinner. What can happen? Shaded or not. What's the probability on each of those? Separately. The second spinner, what's the probability I land on the shaded? 1/2. It's 2 out of the 4, or 1/2. 2 out of 4 again here for 1/2. So are these 2 events independent or dependent? Independent. The first one doesn't change the second one's sample space. Independent. Okay, same thing down here. Okay, the probability that I win. This is what's new today. I want you to convert that into the situation. rewrite this probability with an and or an or, whatever applies. What are we looking for the probability of happening if I'm winning this game? Say it words. And what? Probability of shaded and shaded. Right there it tells you what you're going to be doing. So I'm going to rewrite that as the probability of shaded and shaded. Now you know exactly what to do. What are we going to do with the probabilities? Multiply. So it's going to follow that branch out. 1/2 for the first one, 1/2 for the second one. So the people that guessed the 1/4 were correct. Okay. Second carnival game. You're going to have a bag that has 10 white spoons and 8 purple spoons in it. The contestant's going to draw out 2 spoons without replacement. If the spoons match in color, you win the game. Okay, this one's not quite as easy to see because the probabilities are different. Because you don't have the equal number of spoons. So this tree diagram was not absolutely necessary. You could have just gotten from the picture 1/2 and 1/2, knowing that it's an and. This one's a little more challenging. So let's make the tree diagram. There's 2 events because they're drawing out 2 spoons. So what can happen on the first event? White or purple. We're looking at color. I can get a white spoon or I can get a purple spoon. But the probabilities of each one are not the same. What is the probability I get a white spoon? How many? 10 out of 18 is the sample space. 10 out of 18. Purple spoon? 8 out of the 18. Okay, so we've picked our first spoon. Now we're going to pick a second one. Could be white or purple. Same thing down here, white or purple. And the tree kind of builds in the condition. Because I'm on this branch, I know I've already picked out a white spoon. What's the probability I pick out a white again? Why 9 out of 17? You agree with that? Yeah, because we got 1 white gone, and we keep it without replacement, so that makes a 9 out of 17. What about the purple? 8. All 8 purples are still in there because I'm assuming I picked the white, so 8 out of 17. Okay, next branch. Assuming I picked the purple one out first, what's the probability my second one's a white one? 10. All 10 are still in there, but only 17 to pick from. And the purple? 7 out of 17. So let's take a look. This top branch would be 2 white spoons. Middle branch, white purple, purple white, and purple purple. Okay. So I've done some other probabilities in here. My last one is probability of a win. So let's practice rewriting. So the way they're phrasing it here, I did not give you the and or the or. I want you to be able to take the probability of both spoons being white and convert that into an and or an or, whichever one applies. What would that be? What is it? Kayla? White and white. Both white means they both. It's not white or white, it's white and white. So probability of white and white. So what are we doing with our probabilities here? Multiplying. You just follow the branch out where the 2 whites are. 10 18 times 9 17. And I know you can type that in. We won't take the time to get the final answer here, because you know I care about the work. Okay, this one a little more challenging. The probability of getting at least 1 white spoon. Who can rephrase that? This one's a little more involved. I got to pick 2 spoons. This is your sample space here. Remember, these are the only 4 things that can happen when you pick the 2 spoons. It's got to be a probability. Cooper, you think you got it?
Probability of
There he goes. WW or WP or PW. What would be between each of these WWs and the WP and the PW? What word would be in between that you didn't say? Is it white or white? Or white and white? White and white. So these are ands. I'm going to put a little and in there. But then each case is separated by an or. So white and white, we just did it. That's the 10/18 multiplied by the 9/17. Or tells me to do what? Add the next set of probabilities. Now I got to follow the white purple branch out. What's that white purple branch going to be? White first, purple second. 10/18 times 8/17. The white purple branch is right here. Once the tree is there, then you can rewrite it. They're really easy. And then the added, because I've got or, purple white. Follow those two out. How about 8/10? Oh, I wrote that wrong, didn't I? Now I catch that? Oh, you guys wrote down 18. How many wrote down 10? Oh, see, they don't look at me. They know what they're doing. 18. Where am I at? Purple, white. 10/17. Okay, very good. And then, again, calculator work from there. We won't take the time. What's the probability that you get one of each? You get one of each color. What is it? What did you say, Lydia? W. And what was your connecting word? Or. That's key. PW. You agree with that? There's one of each. If you look at the 4 outcomes, those are the only 2 that have one of each, so she's right. So now you just follow those branches out. Starting with the WP, 10/18. P is 8/17. Or, now we're going down here, 8/18. And white, 10/17. Questions so far? Okay, now we're back to the original question. What's the probability you win the game? And we were winning the game if the 2 spoons matched in color. There you go. So this gets converted to asking the question, what's the probability that I get WW? What did you say the connecting word was? Or. I can win in either case. So WW, 10/18, 9/17. Are you writing your own down, not bobbing your head up and down here? I hope so. 8/18, and purple, 10/17. Oh, wrong one, 7, I went down the wrong one, 7/17. Okay.
You know, Alexis is getting really confused with things, like 5 minutes older than the top and 18 is still 10.
No, it's all good. You got that, Alexis? Figure it out. Yeah, 7. You should have looked on your own, Bridget. You shouldn't be looking at mine. Oh, it is the last one. Okay, what do we got over here? Oh, back to the